Hi, it's Mrs. V, and I am here inside the greenhouse. And today we are going to talk about some natural influences on climate. So I'm going to cut to a PowerPoint and we'll get cracking. Okay, today we're going to talk about some natural influences on climate, and we're going to start, of course, with our learning intentions. So first of all, we want to tell the difference between weather and climate. And a bit of a hint for you here, the difference between weather and climate has cropped up in many exams on global systems, so it's definitely worth knowing, as is the distinction between climate and climate change. So these are important distinctions that we expect you to be able to make. We're going to be discussing some of the factors that naturally influence the climate, and later on, probably not in this particular lesson, but in future lessons, we're going to talk a lot about how ocean currents affect climate and ecosystems. So first of all, weather. What is weather? Weather describes the state of the atmosphere in terms of temperature, wind, cloud cover, and precipitation. Precipitation could mean rain, could mean snow. And weather is something that changes from day to day, and sometimes we get very extreme events. And I'm sure you remember not so long ago the extreme event we had in Canberra of that hailstorm. Climate, on the other hand, is the long-term average of weather conditions. And so it's the average probably taken over 10 years or so. And it is calculated from weather, but it's the averages of the weather that's calculated for many years. But climate can also change. Okay, so some terms we use to describe climate, we might have a tropical climate or a temperate climate or a polar climate. So these are climates. So it is different from weather because weather is that instantaneous day by day situation, whereas climate is a long-term average. Here we see a map with some of the climate zones across the globe. And of course, we can't say that because you're in a tropical zone, you'll never have a dry day. And we can't say because you're in a temperate zone, you'll never have a cold day. It's a long-term average. So what is climate change? Climate change is looking at how long-term weather patterns change, and that has to be over decades or even longer. Usually even 30 years is what we would judge whether the climate was changing. So we'd talk about whether the long-term averages of weather patterns were the same over 10, 20 years, or whether they were changing. So make sure you know the distinction between those three terms. So there are many natural influences on climate, and of course the most obvious one is the sun. The sun is what keeps our planet warm enough that we can actually live on it. And so energy from the sun is a major influence on climate, but there are many other influences as well on the world's climate. We're going to start out by talking about the world's climate, and then later on we'll come down to just what Australia's climate is. But looking at the world's climate, the actual surface of the Earth, whether you're looking at a reflective surface like the ice caps, or whether you're looking at a darker surface like a forested area, that has an influence on climate. Gases in the atmosphere, we're going to focus a lot on the gases in the atmosphere in this particular lesson. The orientation of the Earth, you know that the orientation of the Earth causes seasons. You learned that in Year 7, and we're going to just brush up on what we learned in Year 7 again. And then finally, we're going to be looking at the influence of ocean currents. So let's look at the surface of the Earth. So the characteristics of the Earth's surface determine how much energy is reflected back into space. So clouds reflect the sun's energy, polar ice caps do, and also very reflective areas of the Earth's surface like deserts are able to reflect a lot of the energy from the sun back into space. So these are the regions where the energy is not absorbed. So these areas prevent some extra warming of the Earth. Forested areas, those darker coloured areas, absorb the energy of the sun. So that's really important for warming the planet. Here on this map, this is a picture from your textbook, we can see that the white and red areas indicate more reflection of the sun's rays. And in the green and yellow areas, you get the sun's energy being absorbed. And if you have a look at where those areas are, you'll see that the red zone, well, the white zones are obviously the ice caps. The red zones are a lot of the desert or the tundra areas that are quite reflective. And the green and yellow areas are the more forested areas that allow more absorption of the sun's energy. So gases in the atmosphere, this is really important, and this is what we're going to be focusing on a great deal in this particular lesson. So how does this, how do gases in the atmosphere actually have an effect? Well, the energy that comes from the sun is what we call short wave radiation. So short wave radiation. And that can be absorbed by clouds in the Earth's surface. But when it gets radiated back into space, it gets radiated as long wave radiation, or as heat. Now, the long wave radiation can pass through the gases of the atmosphere, and particularly nitrogen and oxygen. However, that long wave radiation can be absorbed by some gases that are called greenhouse gases. And I imagine you have heard of greenhouse gases. So greenhouse gases are able to absorb that long wave radiation. So greenhouse gases, they let the short wave radiation go through them. So they don't actually stop the energy from the sun getting to the surface of the Earth, but when the surface of the Earth absorbs that radiation and re-emits it as long wave radiation, then we have these greenhouse gases, and you need to know the greenhouse gases, so you need to be able to remember these names of the greenhouse gases: water vapor, carbon dioxide, methane, nitrous oxide, and ozone. They are able to absorb that long wave radiation and actually radiate it back to the Earth's surface. And the heat kind of bounces back and forth in between the atmosphere and the Earth's surface, and that keeps the Earth warm. So the heat gets trapped closer to the Earth's surface, and that keeps it warmer than it would otherwise be, and this is called the greenhouse effect. A greenhouse effect, it's not all bad. The greenhouse effect actually allows our planet to be habitable. So this is similar to the operation of a greenhouse. So when we have the shortwave radiation coming from the sun, that goes in, passes through the glass really easily, and all of the stuff inside the greenhouse absorbs that radiation. And quite often in a greenhouse you have a thermal mass, so you might have a whole heap of rocks on the floor of the greenhouse, or you might have a wall here that's made of stone, but you have some sort of thermal mass in a greenhouse, and that absorbs that radiation. Now when it radiates it back, it radiates it out as long wave radiation, and that can't pass through the glass. So what we have is the heat then bounding around inside the greenhouse, bouncing off the surface here of the glass. And this one will go here and bounce back, and you just keep that heat within the greenhouse by the fact that that long wave radiation can't go through the glass. And that's what enables plants to grow inside a greenhouse in the middle of winter, because the temperature inside the greenhouse stays nice and warm. And that's similar to what is occurring with the gases of the atmosphere. So our glass of the greenhouse would be our greenhouse gases. And we would have that heat bouncing back and forth between the atmosphere and the earth, keeping that area in between nice and warm. So if this is the earth and you've got your gases of the atmosphere, you get the heat bouncing back and forth. Now, probably like that. And this area then around the earth is warmer. And that's called the greenhouse effect. Now, without the atmosphere doing this, our days would be way hotter and our nights would be much colder. The Earth's average temperature would be at -18 degrees rather than +15 degrees without the greenhouse effect. So we hear a lot about the greenhouse effect in the media, and we hear it as a bad thing, but it's not actually a bad thing. It actually makes the Earth habitable. So the greenhouse effect makes the Earth habitable, and that's particularly because it actually stabilizes the temperature on Earth. Okay, it is time for you not to do a practical activity, I'm afraid, but to be watching a video of a practical activity. Mr. Cerruti has made a video of the prac that's on page 192 of your textbook on the greenhouse effect, and I would like you to watch the videos of that and answer the questions on page 192. So that's what I expect you to do for the rest of the lesson. And make sure you've got your notes down from this particular video. You can go back and look at it again. You can pause the video at any time, but make sure you get your notes down and then move on with the prac on page 192. All right, I will see you back in the classroom tomorrow.